tu muszę do WordPressa się dostać, wiesz.
Hello everybody, we are starting, finally. My name is Jacek Ambroży, welcome at IBB. Today we have a training course, we are starting, finally for the first time, but this is for the first time with these products. We introduced on the UK market IBB Therm insulation render system. We are working with this kind of technology like maybe 15 years or maybe 20 years. Of course, 10 of these years was in Poland, Germany, and Sweden, but like 8 years we introduced this external render system in UK. Firstly, we started with our products and with the other companies. External render system in UK. Firstly, like 1.5 years ago, we decided to introduce our own. We try to find the best possible system. We know requirements on this market. We know builders who are using other systems similar to this one. And finally, we decided to start cooperate with Śnieżka. This is the Polish manufacturer, very experienced, very well known. And we decided to introduce on this market the system which they manufacture for us with the name IBB Therm. I will introduce today will be training provided by manufacturers, my colleague and some other. They will introduce themselves because we just introduced each other 1 hour ago. I'm not sure if I could pronounce their surnames. But finally, we, like 1.5 years ago, started to import to this country this product, exactly IBB Therm. It is one of the best, I can say even the best our seller. We choose the best quality, we choose the best product, which is the product which was tested on the Polish market. The requirements are as high as in UK, but the weather, as you know, is completely different. Today we have snow in Poland, for example, yeah? And the minus temperature started. Then this system is proved not only by selling 1.5 years here, but also in Poland. Today we welcome also the representative of British Board of Agreement. They will control, they will listen, and they will correct us. Finally, we want to prepare the best possible materials for the teaching builders and for introducing according to the UK standards. And even the system is today approved in European market. We were strongly interested to test it according to British Board of Agreement standards. Yeah? That's why the whole procedure, which lasts now like more than 1 year, hopefully we will finish soon. Finally, we hope, we will receive the certification. And I will tell shortly how it will be organized today training. We divide this for 3 times 45 minutes and with 15 minutes break. It is one of the longest hour training. But after 45 minutes, welcome to the coffee machine. We try to repair it still, but anyway, there is something hot to drink and there is something to eat. And the training has to be long like this because there is so many important things which we have to inform you, provide and discuss. Then that's why I don't think will be possible to shorten this. Yeah? You have received some materials. And please, if you can keep this catalog, because the training will go through according to this material. Yeah? What I want to say, after the training, we prepared the certificates. I will show you. This is the certificate. You will receive certification. It will be issued by us, and it will be printed. We checked your surnames and names. Please check again, because what is written on our list, it will be written on the certificate. Yeah? If you want personal, for your name and surname, okay. If you want for the company, it's possible as well. But check it, because after that, this list we will send to the printing company and we will print it. I expect 2 weeks' time you will receive it. Okay. And all right, please, I will introduce my colleague, and he will now start with the proper training. Thank you very much.
Thank you. Hello once again. My name is Dominik Czerny. I'm working in a company Śnieżka. I'm R&D manager. I'm responsible for chemical construction technology and facade products. Today I want to say some words about external wall isolation. Okay, let's start. IBB Therm system is a layer arrangement consisting of EPS board, a layer of reinforcement made of adhesive mortar and fiberglass mesh, ready-mixed acrylic, silicone, silicate, silicone and polymer plasters, and mineral render coated with facade paints. The following mortar adhesives are for bonding EPS boards to the background surfaces. IBB Therm PA10 polystyrene adhesive and IBB Therm PMI 11 polystyrene mesh. The isolating material comprises 50 to 250 millimeters thick, in size 600 per 1200 millimeter, produced by Jabelite Limited, BBA arrangement certificate, manufactured in accordance with European norm with the reaction of fire class E. The next component are anchors. In this slide we have a list of anchors which have to use in IBB Therm system. This is QMF, MIT, LFN, Bravol, Fischer, Kellner, etc. The reinforcement layer is made of mortar IBB Therm PMA 11 polystyrene mesh with glass fiber, mesh IBB Therm M145 mesh or M165 mesh. And the last coat is plasters. Before use plaster, we have to use undercoat primer and acrylic primer AU10 we use for acrylic plaster 80-100, polymer top coat PTP 400 mineral top coat MT100 and silicon silicate top coat. Silicate primer are used for silicate plasters ST200, and silicon silicon undercoat is used for silicon plaster ST300. When we use mineral render, we have to paint it. In IBB Therm system, we have the following facade paints: acrylic facade paint AFP 100, acrylic facade paint plus AFP 100, silicate facade paint, silicon facade paint, and silicon silicate facade paint SSFP 250. Before use this facade, we have to use a primer, and we have acrylic primer AP10, which we use for acrylic facade paint plus, and we have silicate primer, which we use for silicate facade SFT 200 and silicon primer for silicon facade. A choice of the system depends on the type of the required system, mechanically fixed with supplementary adhesive or bonded with supplementary fixing, location of buildings, customers' financial capacity or of special purpose. Why is worth to use IBB Therm renders and paints? In this slide we have the list of benefits in this product, and we have double biological protection. Renders are equipped with two systems of the biocidal systems. The first of them is active already during a storage of the product, and the second one after its application, protecting a facade for a long time. The next is stable for manual and machine application of render. Expect mineral and silicate. Excellent adhesion to the substrate, resistance to dynamic stress, high flexibility, and improved resistance to the formation of surface cracks. And you have above 200 colors. And the first step is surface preparation. It's very important. Survey and preparation of the building is key to obtaining a successful specification and finished installation. If this is done incorrectly, the success of the external isolation will be at risk. Visiting the site is essential before works are commenced in order to survey the building and elevations that are to receive the system. This is done to determine what remedial work needs to be carried out prior to the elevation external isolation starting. Our recommendation in this step: check for rising damp and the causes, check for existing movement joints and make provision to reflect this in the new installation, remove moss, lichen, mud, and treat with an anti-functional wash if required, evaluate access to the property, height of the building and security of tenants, contact local building control authority, unless using an installer organization who is part of a SWI person scheme, who can self-certify their work complies with building regulations without the need for a separate assessment by building control. Ensure that the contractor is aware that the eaves and roof zone should have adequate isolation to avoid cold bridging at this junction. Evaluate the need for repositioning of or temporary removal of services such as overhead electricity, TV, telephone and broadband connection, gas or oil pipe work, electricity or gas meters, lights, rainwater gauge, and etc. The substrate must be strong, dry, even, without any anti-adhesive layers, and free from aggressive biological and chemical agents. Low adhesion layers must be fully removed. Such activities can be conducted using sharp-tipped brick hammer, putty knives. Substrates that are strong but flaking on dusty must be cleaned with brushes, dusted and sprayed with high-pressure water from the top downwards. All losses must be treated with IBB Therm PA10 polystyrene adhesive. Now we talk about proceeding with services. At the beginning, about electrical devices. Houses are most likely connected to electrical devices such as overhead cable, clipped service, cable or wall boxes. These are often attached to the front or gable wall. For health and safety reasons, external wall isolation must not be installed over electricity wires and cables, as this creates number of safety hazards, including potential fire hazards. The external wall isolation installer is not permitted to interfere with that kind of wires, cables of equipment. For electrical safety, provision of an electrical supply and the connection of any units to a supply should be carried out by a qualified electrician. The provision of the electrical supply should be in accordance with the EIA wiring regulation. And in England and Wales, all installation must meet the requirements of the building regulation from 2010, Part P. In Scotland, to meet the requirements of mandatory standard 4.5 with reference to clause 4.5.1 of the building regulation from 2004. All installations should be designed, constructed and tested such that they are in accordance with the requirements of BC 7671 from 2008. What about power cable temporarily covered by system? One discussion with electricity supplier has been undertaken. Option to maintain cables on wall may be agreed with cables to be disconnected and then the new cables installed once works are completed. Install double timber buttress to protect existing cables and provide grounds for a new cable. If the agreed detail is to relocate the cable during the works, the system should be installed with a throw carefully measured to minimize patching effect. The render system should be left short of the isolation board. The cable should be removed from the wall and relocated to the outside of the new system. The gap in the system should be filled with isolations and the rendered finish lapped with the existing installed system and the finish applied. This issue should be identified during the site survey prior to any work starting. This is a slide which shows what I say. What about air vents? All homes require appropriate levels of ventilation, so before starting any work, the approved installer should carry out an assessment of the existing ventilation provisions and should inform the homeowner if there is insufficient ventilation or if the existing ventilation has been adversely affected by prior actions, highlighting in particular any inadequacies in ventilation of rooms with fuel burning, heat producing appliance. The external insulation should then be applied without compromising any existing ventilation provisions. Prior to commencing the installation of external insulation, the air vents should be removed, and after installation of external insulation, extended to the external surface of the installed system. Next, gas pipes. Very important. All works connected with the gas pipes and gas boxes should be carried out or acceptable by an approved operative under the gas safety regulation. It's very important. Best practice would be to move the existing gas pipe. However, timescales do not always allow this. It is critical that the trims used to create the void are fully sealed with a silicone mastic sealant so that no gaps are evident to allow any gas which can leak from the pipe to move behind the external isolation system and build in the void created. To avoid the ingress of water and for aesthetic, a PPC aluminum vented cover plate should be installed fixed to the external isolation system using the spiral anchors and screws. Gas boxes. Metal boxes are surface fixtures that without removal and repositioning on top of an external isolation will present a significant cold breach throughout the installation. In all cases where practicable, the metal box must be repositioned and secured on the top of the external isolation system using special thermal isolating fixing blocks or other approved detail. The mounting system must ensure the water integrity of the detail and appropriate sealing solution must be employed to ensure that water cannot enter the external isolation system through gaps or as a result of cracking in the render finish. When this approach is not practicable, stop the application of the external wall isolation system short of the meter box and install a water return in render or full stop bit. Following installation of external isolation, all metal boxes must have a minimum 25 mm gap around them for access and maintenance. An example of such way box treatment show this model. Maybe it's not gas boxed, but we want to show a gap around the box. The gap have 25 millimeters. What about gutters and downpipe? External drainage pipes will generally have to be relocated as the wall thickness will be increased on the outer face. Where jellies is impeded by the isolations, they may need to be relocated. This issue should be identified during the site survey prior to any work starting, as there could be significant cost amplification. Extra flues. Existing extract flues should be extended using a proprietary extension pipe to the depth of the new external isolation system. The extension pipe should be secure and fully sealed against the existing substrate. Where existing balanced fuel extract pipes cannot be extended, there should be an allowance to return the isolated render system back into the wall to create arases and provide a seal to assist shedding of water. test of substrate, assessment of structural performance for individual installation should be carried out to by a suitable, qualified and experienced individual to confirm that substrate work has adequate strength to resist the additional loads that may be applied as a result of installing the system. This slide is introduced to presentation Mr. Gary Robinson, and we invite here. Maybe we take a break now. Invite you a break because we have a change of presentation.
My lights are load up. My presentation.
Just a start process.
regards to wind fixing and assessment for external wall insulation. I think no one's going to expect you to be able to do a wind load calculation or an assessment. I don't think you'll ever be required. Although if you do, I'm sure I can break it down into a bit more detail for you. But I think the purpose of the talk is to demonstrate that there is a distinct process that we go through in order to determine the type of fixings, the number of fixings, and the layout of fixings on EWI. And it's very important that what's specified is installed on site in terms of embedment depth and fixings, because it has some very serious consequences. And I think cladding currently has a little bit of a bad name, particularly unfairly for external wall insulation cladding, but since Grenfell, so I think it's important to show that we go through a process and what we put on the wall is correct and in line with recommendations and guidelines. Okay, so again, so it's a technical presentation. So I'll give you a bit of background in terms of my, just in terms of myself. I think the purpose of that is to demonstrate that when you are involved with procuring wind load fixings yourself, you need to make sure that the person is correctly certified and indemnified. I'll look at the importance of wind and fixing testing. I'll give you a few case studies to scare you a little. I appreciate that I think it's more important for high-rise structures, and I know this is particularly focused on low-rise, but it's to give you an idea of when things aren't done correctly, there are consequences and there are failures. Look at the type of failures and where we can eliminate those on site. How, what influences wind and fixing calculations, and again, how does that affect you on site? Also, to verify that the fixings that we choose or the adhesive that we use is correct and appropriate, we do some on-site testing. We do this because one type of brick is very different to another type of brick, and then depending on where you go, if it's on the coast, by the sea, chloride ingress, you can lose a lot of strength. So what we do is we test on site, and what that allows us to do is it allows us to look at whether the information we use to design that fixing is appropriate for that house. And of course, if you might be on projects where you do 20 houses or 100 houses. We'll also look at how many tests you need to do, whether you just need to do one house, whether you need to do 5 houses, X number of houses, just so you can get an idea of what is safe and what is appropriate. Okay. So I'm a structural engineer. I have a doctorate in structural assessment. I've worked in the EWI industry since 2009. And I've published research journals and conferences both on precast structures and also on structural external wall insulation products. And some of the projects that I've been involved with. Okay, so the importance of wind and fixing assessment. Again, so failures when they happen because of the weight of the systems. It's obviously something that we want to avoid if it's 6 to 8 millimeters of render falling from height. These two pictures are adhesive type failures, so it's a pull-off peeling failure, and that is due to wind suction. So as the wind hits the building, it sheds, and then that suction pulls off the adhesive. Again, a few adhesive failures and also failure of the fixings. So the fixing failure is probably the least likely to occur. But again, I put that up there because when fixings are specified from EOT or Fisher or X, it's important that you use that fixing because it goes through the correct quality assurance procedures. It's stored in line with the manufacturer's requirements, and it's installed in line with the manufacturer's requirements, embedment depth, etc. It's all very important because it stops the fixings failing.
So I can ask a question?
Of course you can.
Those first photographs with the peel-offs, were they not mechanically fixed?
No, the first one is, so you can see, sorry. Yeah, so they certainly the one on the bottom right, and there's globs of adhesive.
And that's it?
That's it,
Right.
yeah. So adhesive systems are fine. The adhesive is very strong. and it's particularly strong in a test environment, in a lab environment, but I think it always falls down on site because of surface preparation, environmental conditions, and I think particularly for Śnieżka, it's the hybrid, so it's fixings and adhesive, or mechanically fixed only. But while in the back of your mind you probably think, well, a mechanical fix has an advantage over adhesive, there's also examples of mechanical fixing which I'll come on to now. Okay, so this is a high-rise block in Liverpool, Stanley House. You can see this on YouTube. And again, this is an EWI system. It's a high-rise block which heightens everything, and this is mechanically fixed only. And it might be a bit of delay, but essentially what you see, this is I'll let it fall through. I don't know why the bloke was filming an empty, but there we go. So again, it's a bit of sensationalism to highlight the importance, but that was a fixing failure, mechanically fixed only of a high-rise block. So, Stanley House in Bootle. It's a coastal location, and it was a reinforced concrete frame with brick infill panels. So they were fixing into the secondary brick masonry panels. The second example I want to show you again, it's high rise, so it's scary stuff to a certain degree. Now, this wasn't a mechanical or an adhesive failure. So what happened here was, you can see on the right-hand side that the render, it looks like it hasn't been finished. But what has actually happened, you can see that all and every fixing is still in place there. So there hasn't been a failure of the fixings. What's happened there is what's called a delamination failure. So with your ETIC system, you have your fixings, your insulation, your mesh, and your render. And then in any part of that sandwich, it will fail at the weakest part. And what's happened here is it's delaminated, so the render has peeled away from the insulation. And so this is important the BBA will probably know better than most, but it wasn't one failure here. It was a series of shortcomings, but a lot of it was to do with the conditions that the mineral wool was stored in. So if you store your mineral wool in the wet, in the damp, in the cold, you get problems if you apply your render when it's cold. So again, it's just to highlight the importance of installing everything in line with your training. Okay. So there's numerous ways your system can fail. So you can either have failing of the fixing, the failure of the adhesive. The fixing can actually pull out from the substrate, or we get what's called a pull through or pull over failure. And that is, I've got a picture, not an EWI, but I'll show you it in a minute. But pull through is essentially the insulation pulls through the fixing. So it's to do with if you don't put the correct washer on. Sorry,
just a question. So in case if the fixings are okay and the render is still clean off of the mineral wool, who's taking responsible for it? Is it the contractor or is it the manufacturer, the supplier?
Well, I think it's an important question, because the Wyndham project, it was a numerous failings. So the design was shown to be it could have been improved. The installation, the storage could have been improved, and the approval could have been improved. So it wasn't one failure. What I would say is that you need to make sure that the system you use is accredited by BBA, is designed by an engineer, and then you follow the process and the procedures. I think if all of those are in place, then it won't fail. And I think wherever that process, whether it's the system design, the approval, or the installation, wherever that process fails is where the responsibility lies. But I think to get to a false failure, I think it's never one link. It's always numerous things missed. But yes, so I think to answer your question, there's chance for it to go wrong, and it's the fault at distinct points in the process. But the important thing is to make sure that all of those parts are in place, really. Okay, so we've got pull through, so it pulls over the insulation, and then you've got two types of delamination, so this peeling effect. So you either have peeling where the insulation peels away from the substrate, peels away from the brick, or you have the failure at Windham where the render peels away from the insulation, so there's two parts there. And then I think, apart from the failure of the fixing, the least likely to happen is if you actually get a failure within the insulation. Just some examples of the failure, so the adhesive and the fixings. And then when we talk about pull-out failure, so that is when you fix your fixing into your concrete or your brick. When you pull on it, you have a cone, and what happens is that the fixing pulls out a lump of the concrete and substrate, and that's what we call a pull-out failure. And then a pull through or pull over, that is where you have your, I couldn't find a good picture, despite how many tests we do, of where it fails over the insulation. So this is a fixing within a steel wrinkly tin, but it's the same effect. So it's the washer deforming and actually pulling through the material, and then delamination, which we've covered before. So hopefully that gives you a bit of an idea as to why we do wind load effect calculations. And what we look at is numerous things, whether it's the distance of the building from the coast, because if you're right on the sea, you'll get a higher wind load, how high up your site is, the height of the building, whether it's a 6 to 8 metre, 10 metre house, or whether it's 3, 4, 5-storey buildings, all the way up to the high-rise blocks that they do in London and Scotland. The size of the building, how big you are on plan, affects localised regions. Whether you're positioned to north, does anybody, well, don't worry, so the predominant wind in the UK is from the southwest. So if you ever watch the weather in the morning, most things come from the Atlantic, from the southwest. So depending on how your building is orientated affects how much load is on the building. Whether you're on the town or the countryside, orography is a very pretentious word for how many hills surround your building. And then also if you have, say, within inner city London or Manchester, you get shielding from surrounding buildings, but you also get a funneling effect. So if your building's very close together, it's like if you have a hose pipe and you put your thumb over it, the water goes faster. So again, you get this funneling effect, and we need to account for that within the system design. So all wind loads are, again, you don't need to know this really, but I think it's useful to have a bit of an understanding of where the system comes from. All systems, well, all wind loads are done to European codes. The most current code is Eurocode 1 or BSCN 1991. I think an important thing that might come up is that structural engineers still design to the old British codes. Now, wind and gravity hasn't changed from 2000 to now. It's not changed significantly from how we used to design wind to how we do now. But the important thing is to make sure that if you do get an engineer to do your wind load calculations, is that he uses the most current codes, because that incorporates the most current research and the most appropriate practices. Also, when you design to Eurocodes, you use what's called a national annex. So you can use a Eurocode to design in France or Germany or Poland, or in the UK. However, you use the national annex because that deals with local conditions. So the wind within the northwest of England, we better understand that within England than a Polish engineer. So as long as you use the correct national annex, your wind loads are correct. There is also INCA, which is a professional body. They produced a technical guide on how to do wind loads. Specifically for external wall insulations, they look at both a mechanically fixed and adhesive fix. They don't deal with when you use both adhesive and mechanical fixings. So you always need to be looking to use a qualified and indemnified structural engineer. These rules they're not written down. This is something that I try to advise people on. Now, if you the question is whether you need to do a wind load calculation for every single house that you put an EWI system on. If you think of the cost of doing that, it would be prohibitively so. But what's important is that you talk to an engineer and they identify the risk of when you need to do calculations. Most buildings can be designed to 0.85 to 1 kilonewton per metre squared. Again, you don't need to remember that figure, but it's a figure that engineers use to say they can assess the system and look at whether that would be appropriate. However, where buildings are particularly go higher, whether they're above 12 metres, whether they're non-traditional constructions, so in this country there were lots of wacky, weird and wonderful ways to build houses after the war. So a lot of the houses aren't brick built, so I wouldn't say a lot, but there's a significant proportion of timber, steel and precast concrete houses, so Boswells, I'm trying to think, Aries, Swedish timbers. These houses exist, and where you're putting insulation onto non-traditional buildings, you need to be assessing the wind loads, because it's not simply a case of going onto brick. You're going onto a system, particularly in the case of concrete buildings, precast concrete buildings. They're structurally deficient, so the BRE have said that you can't get a mortgage on them. They're not going to collapse, but what it means is that if you're adding extra load to it, if you're adding weight, if you're adding, the wind load doesn't change, but you're changing the way that load is applied, the building is deficient anyway, so you need to carefully consider whether putting extra load is appropriate. And when I shouldn't use the word you, it's we as a design team need to make sure it's appropriate. And also if it's a zone 4 exposure class, so even if it's a low-rise building, but if you're near the sea, or on a particularly exposed island, you would need to consider the wind load. So we consider distance from cities to the sea, orientations, and then again that gives you an idea of 0.5 to 0.8, 0.51 to 1.5. Engineers can get a good gauge of whether your system is appropriate. So quite quickly you can see whether your system will work without doing the full calculation. On-site testing, so we need to look at pull-out testing, adhesive pull-off tests, and ongoing sampling. So we've looked at the building, we've seen it's a brick building, so I could look at Hilti or Fisher or EOT, and they would tell me into brick I get a load of X. And I could say, okay, now we have 5 fixings per board, away you go. Now, as I said, the brick might be, there's a big difference whether it's London brick or whether it's a Yorkshire brick. The strengths can vary quite quickly, and also for existing buildings, they can degrade. So what we need to do is we need to check that the figures that we've designed the system for match what we actually find on site. And the way we do that is we use this is called a hydrojoules. So it's a hydraulic system that you fix your fixing to the specified embedment, and you apply a torque or a pull out, and then you record the load that pulls out at. Now there's various guidance that tells you if you did one test and it said you get 1.5 kilonewtons, and you said, well, we get 1.5 kilonewtons, you have no idea whether that one test that you did was the strongest bit of the building or the weakest bit of the building, or whether it was an average bit of the building. So you need to do a number of tests to make sure that the readings that we get are give the engineer an accurate reflection of what the building is. And that includes, I'll summarise it later on, but if the bricks change, so if you have different coloured bricks, or your bricks look in different condition, or the construction type changes from brick to cement particle board, you need to do tests at each different material, and where it looks like the material changes. So the more information that we can collect from the testing, the better the design is, so we just make sure that we don't miss anything. The worst thing you can do is just do a few tests. I've seen cases where people do 3 or 4 tests, and they take an average and then they apply that to design, and it's just wrong. You need a minimum of 15 tests, which again I'll caveat that slightly, but as a rule of thumb you need to be doing 15 tests, pull-out tests on a building to tell the engineer this is how strong our brick is. Adhesive, to codes, you're usually doing 5 tests to get a reasonable average. Now, again, you need to be doing those tests everywhere that your material changes on elevation. So where the block changes, where the brick changes, you need to be doing a test. The adhesive tests are slightly differently because you're doing it to demonstrate a minimum value rather than a maximum value you get from a failure. It's to do with the statistics analysis that you run, statistical analysis that you run. Again, if you're particularly interested, I'm happy to talk you through it. But the important thing that you need to take away is that you need to be doing tests. You need to be doing at least 15 tests, and you need to be doing it everywhere that the material changes, or it looks like there's a problem. Because what it does as well is it allows you to identify where there are issues on the building. Because if you pull a test and it pulls at 0.1 kilonewton, it's telling you that your brick's soft and you shouldn't be covering it up and fixing it with fixings.
So I can ask,
of course you can.
When are you doing these tests? Are you doing this before you start the building work as on the survey?
Yes.
At the beginning?
Yes.
This isn't once you'd actually put it
No,
together?
but what I'll caveat that as well is because if you're doing one house, someone should come out. They should be pulling the 15 tests. They should be checking that they meet the requirements, and then you should be rendering over it. However, if you're doing 20 houses or 50 houses, what you don't want to do is to do one house and to say this is okay for all of the houses, and covering them up. What you do is you need to carry on doing a number of houses. So I think I've got the exact guidelines later on, but yes, you should be doing them before you get on site, really. So that because again, you don't want to be on site and someone saying the brick's not right. It's a weak brick or something of that nature. Yeah. Okay, so how many tests should we do? So you're looking at 15. And why do we do that number? You do it again because if you did lesser, if you did 3 or 4 or 5, you get an average, but the value that you have to put on what's called a safety factor. So if you only did 5 tests, you have to divide that number by a really, really high safety factor. So if you only did 5 tests, you might find that you need an awful lot of fixings. You might need 12 fixings per board, where in reality you probably only need 5, but you now have to use more fixings because you didn't do enough testing. Where should we do the tests? Everywhere the material changes. Number of fixing types tested. This is I suppose this is just a practical advice. What I've seen in the past is before the project starts, someone will go out with one type of fixing. They'll do 15 tests. They'll send it to the engineer, and the engineer works out that it fails or that they need a very large number of fixings, but they've only got one fixing. So to go to the next fixing, they then have to go back out and do the testing again. So just a bit of practical advice. It might be if there's a range of, say, 3 to 4 fixings, I would maybe take 2 and do 15 tests for 2 fixings. And then if one doesn't work, the lower grade, you can go to the more expensive fixing. What should we be looking for in the test? Again, what you should be looking for is the figures to be very similar. What you don't want is you don't want some tests at 0.3, 0.5, and then other tests at 4, 5 kilonewtons. That's because, again, not to go too much into it, but the variation is what's called a standard deviation. And if you have a large variation, you need to apply a large safety factor again. So when you're doing the test, if you're getting a lot of variation, you need to be informing the supplier and the engineer because there might be a problem with the buildings.
Sorry.
Okay.
Just a quick one. Is it any legal requirement to do this? And if it is, then who's responsible for it again?
There is a requirement. There's a requirement to the BBA so the certifying body, that this process is in place. You also have to meet building regs, so Part A of building regs. So if it's signed off by a building control officer, they would be asking for this information. So yes, there is a legal requirement, but it's driven by the building control officer. So the process is if it's certified under building control. But yes, there is a legal requirement to do it.
There is a contractor that is responsible for it.
Again, the responsibility is spread. So often the suppliers, again, it works out on how the contract is formed. But suppliers or contractors generally lead the process. But the supplier is what is certified under the BBA. And then subcontractors can be certified under the BBA as well, and they need to meet certain PAS regulations and what have you. So it's led by the suppliers and the contractors, really.
So let's say the supplier is going to tell you, well, that's actually the fixings you can use.
Yes. So it's
But as a contractor, we haven't done the test.
no.
Then is it something that if something's going to happen, then it's coming back to the supplier or it's coming back to the contractor? Or?
I think the purpose of me doing the presentation is to highlight to you that someone needs to be doing these tests, and it needs to be captured in the contractor, not because the worst thing that happens is you do a project with Schnetzke and you've used 5 fixings per board, and therefore in the next project you just use 5 fixings per board and you put it in an airy house and it fails. And I think it's just what you need to be doing is someone needs to be saying, we need to be doing these fixings, we need to be doing a design, it needs to be captured within the contract, because building control will be asking for it, and the BBA may come to site and say, where are your wind load calculations? And it's so it's important to capture it, and I think that's what the purpose of the presentation is, to say that someone needs to be doing it. Okay. Right, so when you do your pull-out tests, you need to make sure that whoever does the pull-out tests, you need to make sure that the fixings that are tested are the fixings that you use, the embedment that is testing is the embedment that you use, the substrate that is tested is the substrate that you use. You also need to check that the machine they use is calibrated, because again it would be there's a big problem if you use an uncalibrated hydrojaws machine.
Excuse me, one question please. Are these machines widely available at high prices, or is it always best to invest in one?
I think you can buy them. They're I think I'm trying to think now. They're not cheap. They're about £2,000 for hydrojaws, but you need to make sure that it's calibrated and the training is to use they can use them. I think in the first instance it might be worth a lot of the fixing companies do this. So EOT or Hilti will do this testing depending on how many fixings you buy. But you can buy them readily available. But what I would say is it's important that you get the correct training to make sure that they're calibrated, to make sure that you can use them. So this is pull-out testing is a piece of documentation that you or the contractor needs to be keeping hold of to demonstrate that the testing has been done. And again, you're recording the front of the house where there's testing on the gable, the type. So it's auditable. So if someone comes and says, "Can I see your records?" They're all in place. With the next calibration date, also an important factor. We then take that data and we can check whether it's 5 fixings or 12 fixings from the testing that's done. We can make sure that you've used the right amount. I'll come on to it in a bit, but an important thing to bear in mind is that what you shouldn't be doing is, if you do testing and it tells you that you need a lot of fixings, what happens is so say you have 5 fixings per board or 12 fixings per board, if your calculations are coming back and someone's saying that you need 25 fixings per board, 30 fixings per board, you're using the wrong system, you're using the wrong fixings, and it's actually quite a dangerous process, because what happens is, if you can think back to where you had the pull-out cone, if you have too many fixings per board, those cones start to overlap. So you're trying to use too much of the substrate. So if you're going over, I think Schnetzke use up to 12 fixings per meter squared. If you're going above that, be wary, because there'll be a maximum number of fixings on the BBA certificate, and you shouldn't be using more fixings than that, because it's not safe, because you're using too much of the substrate. Okay. When you're doing the test, you're doing the test to failure. So what that means is it actually pulls out. So you actually tension it up until you get a failure, till the fixing pulls out. Now, a lot of people don't like that, because it leaves big holes in the brick. It'll damage the elevation. There are alternatives. Construction Fixings Association says that you can do proof tests. So what I've told you about the testing is that they test it to the actual failure, but you can actually test the fixing up to a proof load. So you test it up to 4 kilonewtons, 5 kilonewtons. That's fine. It needs to be agreed with the engineer, and your safety factor is adjusted, but what it means is that you can do a proof load on your tests, but just make sure that if you're doing proof load testing, that the engineer is aware of it. If you're doing failure testing, the engineer is aware of it. It just needs to be agreed and captured correctly. So how does it affect you on site? Hopefully what I've got across is that you need to your quality assurance procedures need to be in place. I've probably said this a number of times, but excuse the repetition. But the fixing that's specified, the embedment that's specified, the number of fixings, the layout of fixings need to be as specified, because a lot of calculation and assessment goes into that. And if it's varied, you're invalidating what has been designed. Percentage of adhesion, again, it's really important. If it's 80%, don't be applying 60%. It's just following good site practice, really. It's just good QA. Pull through of fixings, just one to bear in mind is that when you test a product to BBA or ETAG or Kiwa, the value that the fixing pulls out from is different in the middle to at the joint. So the value that you get for this fixing here is less than this fixing here. So if you use this fixing layout where you've got your fixings at the joints, the load is less at the joints. Through pinning is a process that's used widely. So you put your fixings on, you do your first coat of mesh, and then you can through pin the fixing. That stops a pull through. Some people choose to do it, some people don't, but just make sure that if it's required, it is done. Maximum number of fixings I've touched on. Don't go over the maximum number of fixings because it's structurally unsafe. If it's hybrid system, if you're using an adhesive and a mechanical fix, you need to be putting in a number of fixings, usually 2. You need to put those in because you need to make sure the system is secure until the adhesive is set. So you apply the adhesive, a number of fixings that's specified, usually 2, and that stops the system pulling off in the temporary condition. So if you get a storm come through before your adhesive sets, you don't want the thing pulling off. So again, just beware, if it's a hybrid system, you need to be putting in those fixings. Fixings in the temporary condition. And then the number of tests ongoing with sampling. Again, it's guidance more than anything, but for projects over 20 houses, the SWIGA advise that you need to be doing 5 random tests for every 20 properties. So you do your tests before you start on site, but if it's a big scheme, you need to be doing 5 tests, or somebody needs to be doing 5 tests for every 20 properties. And again, it needs to be recorded and auditable for any certifying body or the building control. Okay, thank you very much. Does anybody have any questions?
When you said the last one, to fix and required,
Yes.
where would that be? On the edges or in the center?
It's usually, well, I suppose perhaps not with this because it's a hybrid system. So usually it would be adhesive and those 5 fixtures, but as a minimum, I would say you need to be putting 2 diagonally, so an adhesive and 2 fixtures diagonally. Yeah.
It's important anyway, because if you don't, if the edges start to peel up, then when you then start to do your render, you've then got problems with your edges.
Which is why, when there is 5 fixings, I think purely adhesive systems really sell this. But you're right, I think the benefit of all adhesive, a hybrid, is it stops the things curling up, doesn't it? Yeah. Anybody else? Yeah. Great. Thank you.
And obviously the different bricks, obviously I know some of the guys, we use the Pullout bricks, obviously, which is obviously completely different brick structure compared to like a sort of solid
Correct.
brick.
That's it. I think that's the biggest one. If you're fixing into a thermalite or a Pora Therm compared to an old-fashioned Victorian brick, it's massive. So in a centre of a Victorian brick, you're going to get some really high loads, but in a thermalite. So, and then often you'll see for houses, people knock out large amounts of wall and they fill them on with thermalite. So you just need to make sure you capture that.
How about if it's the surface of the pebble dash? What do you want to do?
With pebble dash, you need to be fixing to the substrate. So yeah, so your embedment needs to be to the structural. So you don't want to be fixing into the sort of rendered pebble dash. You need to be fixing into the brick or the block behind that. So yeah, you don't want a pull out to the pebble dash. It's straight into the brick.
Sure.
Oh, sorry. Yeah. No, go on.
Yeah, what if the facade is already painted?
Painted? How do you mean?
Well, it's like it's brick.
Yeah.
But it's been already been applied to it, exterior paint.
But I suppose you're covering it, aren't you, with render? Or what's the?
So that shouldn't be a problem.
No. You need to be testing it. Yeah.
Well, I guess it's maybe talking about the adhesive, because obviously the adhesive, if it's sticking to the paint,
Ah, yes.
then obviously you're only sticking to the paint.
Correct.
rather than actually building it.
Correct. So you're testing so your surface preparation needs to be as specified. So if it is grind off the paint but what you need, the important thing of that is, so say you have areas of elevation that aren't painted and areas that are painted. When you come to do your pull off, or the person comes to need the pull off, you need to be saying, I don't just want to be testing the good bit, because the old trick is you go to the very best bit of concrete and you do your pull off, and that's your best value. But you miss the bits that have been painted, or the pebble dash, or your pebble dash might have been referring to adhesive. But you need to capture those variations, because if it is painted, you need to know whether that fails, because there might be a surface preparation that's required. So the important thing is that where it changes, we need to capture that.
And so probably answering, so therefore potentially, obviously on these demonstrations, we've just got the one sort of standard fixing, but potentially, depending on what the house is,
Correct.
you might have different fixings for different areas.
Correct. So it might be a hammer fix or a concrete screw, or so it varies depending, because again, if it's a thermalite or a porous block and you're getting a rubbish fixing, those aren't appropriate, so they'll change the fixing. You're right. So correct. So the presentation before, he had a list of approved fixings, so it would be one of those that you do.
Right. Okay. So you wouldn't necessarily just be using the one made.
Correct. You wouldn't just use the one hammer fixing. You might be using correct.
On some occasion, when you block basically
doesn't hold, are you able to use resin on it, basically? Because resin on used for the RS shade as well as a foundation. So
yeah, well, in high-rise buildings, so Hilti have a range. Well, so do Roll and EOT resin fixings. They do. So yes, you are. Again, I would say that where you're using that, it needs to be specified and approved and designed. So it's not something that you think, right, well, I'll use a resin because it's a stronger load. But yes, you can. Yeah.
And going back to when those large pictures we showed of that high-rise block where all the render come off, that was a mineral wall.
That was a mineral wall. So the problem with that was we had two issues. It's mainly again.
Yeah.
The I don't know whether BBA published anything on this, but it's it was essentially to do with the render pulling away, so from the insulation, but that is to do with the mineral wool was stored wet, and You may have seen advantages of through pinning the mesh. So you apply the mesh, the render when it's wet, and then you fix into that to stop that delamination. But it's all about. It's a funny thing as well, because when this happened, you would think mineral wool is a poor material because when it gets wet, this is likely to happen. However, mineral wool is amazingly fire resistant. So now everybody's using mineral wool, but the important thing is that when you store it dry, because then it works.
So that would have worked better to say if the render had been applied and then fixed through.
Yes.
Fittings on top of the
Correct.
render,
Yeah.
you wouldn't have that result.
Yeah, you get that. It's got a through pinning practice, and that you don't get. What happens is you don't get the pull through failure with that, and it would have meant the bond between the render and the insulation was much better. Yeah, that wouldn't have happened. Yeah.
And lastly, talking about the fire thing, obviously with Grenfell, are you relevant with this? You know, with the regulations on polystyrene compared to the mineral wool?
I'm pretty conversant. So Class O, Class A, mineral wool is the only insulation type that is non-combustible. There's various ways and testings, usually, but for what we're doing, but anything over 18 metres is when fire regulations really kick in. So for low-rise domestic, it's below 18 metres, so EPS is appropriate. When you go above 18 metres, So again, it's one of those things. Grenfell, Grenfell it's not something we didn't know happened. It's not something the regulations aren't put in place to stop. It's just that there were a number of failings, a number of checks didn't happen. But yeah, over 18 metres is when fire really need to be thinking about EPS, low rise, you're okay.
But this type of method wouldn't have allowed it because the wind wouldn't get, the fire can't get up behind it, can it? Whereas
if you put appropriate fire breaks in, so if it's above 18 metres, you should be fire breaks. So there should be mineral wool at every floor to stop. I suppose I'm not fully conversant with what was exactly installed in Grenfell, but the fire breaks are designed to stop that spread of fire. So you can be using EPS, PIR, phenolic, as long as you appropriately fire break, or as long as you appropriately test. So you can, so at the BRE they do BR135 is a fire test, and you can put insulation types on there and fire test them.
Because they were using a frame, weren't they? I think.
Correct. So you get a chimney effect.
Behind,
And then
allowed the,
yes, and I think I alluded to it a little bit before in the fact that overcladding or cladding has all been lumped together, while what we do, EWI, is very different to the panel systems that were used.
I'm doing a building of 3 floors,
Mm.
and the building control required like a fire break between
Yes.
the floors.
Yes.
So we sort of fire break will have.
Mineral wool fire break. It'll be a strip of mineral wool, and you put it between the floors. So is it above? It's usually if you're above 18 metres, but so at the floor there should be a barrier of mineral wool, and that just stops the fire spreading. So mineral wool is non-combustible. Externally, correct.
So when I put this board insulation and then I dig gap, I put mineral wool.
Correct.
How much I have to do?
They'd be specified by your fire engineer or the building control officer. So they'll specify the thickness, but yes, a band of mineral wool.
And then I put another insulation and render over it, or?
No, it's usually stopped, so it's usually EPS mineral wool. Your insulation, a band of mineral wool, and then the EPS. But again, you need to.
And the rendering
and the rendering and the mesh. But then you need to make sure. But you need to make sure that the specification is agreed by the building control fire officer and the system designer, because it's all the render is tested for spread of flame, and the detail will be approved. So you need to make sure what you install matches the detail from the designer, but it's that break between the EPS and the mineral wool is the important thing.
but he said he's only going 3 floors up.
Yeah, usually it's 18 metres, but the building control, the authority rests with the building control. So, but as a rule, 18 metres is your limit. Is that anything else? Brilliant. Thank you very much. Thank you.
Like to say some words about installation of ethics and the beginning about installing base profile. Base profile is a thermal insulation system element which facilitates correct fixing of the system elements and protects the bottom section of the EPS boards against airflow between insulation boards and walls or mechanical damage. Such base profile ensure correct leveling and the obtaining of a straight line from which to start the system assembly process. The base profile is secured to the external wall above the DPC using the approved profile fixing, at least 3 pieces per running meter. Base profile connector are inserted at all profile joints. Before the reinforcing layer is applied, the location for aluminum base profile must always be reinforced by encasing a square glass fiber mesh in IBB Therm PMA 11 polystyrene mesh. Whenever a base profile is used, it must be applied in such a manner that the thermal insulation is fully covered with an adhesive reinforcing layer. The failure to secure the thermal insulation with adhesive may result in material and insulation damage, for example by rodents or other pets. Trims are set above the DPC level to reduce the effect of splashback of rainwater, dirt and other contaminants. Okay, positioning and securing installation boards. Very important is that for the IBB Therm external wall insulation system, EPS boards meeting the following requirements must be used. Facade tape styrofoam board of fire class E, tensile strength perpendicular to the face surface of at least 100 kPa, size of the board 600 per 1200, compressive strength at 10% deformation 70, seasoning for periods allowing them to be used in thermal insulation system, and rough surfaces. Like I say, we have two types of system. Adhesively fixed with supplementary fixing system and mechanically fixed with supplementary adhesive system. The insulation board are bonded to the wall by applying the correctly prepared IBB Therm PA10 polystyrene adhesive or IBB Therm PMA 11 polystyrene mesh adhesive mortar to the board using the strip point method. Preparation of the product is described on the back, and we have to use this described. Very important is that we can't apply not on hot substrate. During application, it's necessary to avoid direct sunlight, strong wind and rain. Substrate and ambient temperature during application and over the course of 24 hours must not be lower than 5 degrees. We use strip point method. A circumferential ribbon of adhesive at least 3 cm wide is applied to the insulation boards. 6 to 8 evenly distributed patches of adhesive, 80 to 120 mm in diameter, are then applied to the board so that an adhesive surface of at least 40% is achieved, 60% after application and pressing. This is for adhesively fixed with supplementary fixing system. For mechanically fixed with supplementary adhesive system, we use the same adhesive and we use the same bonded method. But a circumferential ribbon of adhesive at least 3 cm wide is applied to the insulation boards and 6 distributor patches of adhesive 80 mm in diameter is less patch and smaller, then applied to the boards so that an adhesive surface of at least 40% is achieved after the boards has been pressed against the wall. This is a slide which show strip point method. What is important? Subsequent rows of installation boards are installed above the DPC on the top of the starter track and positioned so that the vertical boards joints are staggered and overlapped at the building corners by the at least 20 centimeters so that they form a tooth finish. In the middle box show this. Generally, boards should be cut in an L shape around the corners of openings, and small cuts of boards are not allowed. And this is the panel in shape L, which we cut yesterday. Boards should be level so that the base coat and decorative finish are installed on a flat true surface, and gaps in boards should be limited and should be filled with expanding foam. Installation of mechanical fasteners shall commence no earlier than 24 hours after the isolation panels have been adhesively fixed. Holes are drilled into the substrate to the required depth, one fixing on the middle of the board, plus a fixing at each corner joint and a fixing in the middle, along the top and the bottom edge of the boards. This represents 3 fixing per board, resulting in approximately 4 fixing per square meter. The mechanical fixing securing the board to the substrate, that number of fixing would be increased as required depending on the location of the building and wind load. This is for adhesively fixed with supplementary fixing system. For mechanically fixed with supplementary adhesive system, details of mechanical fixing are specified in the project specific design requirements based on pull-out results and wind loading data. A minimum of 6 to 8 mechanical fixing per square meter should be installed, unless otherwise specified in the project specific design. This say Mr. Robinson. Okay. Before the reinforcing layer is applied to the thermal isolation surface, reinforcing inserts must be mounted in all corners, windows and doors. This procedure consists of the oblique fixing of rectangular reinforcing mesh strips, at least 20 per 35 centimeter, in order to provide additional protection against cracking. We prepare like this mesh strips. All reinforcing elements must be encased using IBB Therm PMA 11 polystyrene. It is also necessary to use profiles to secure all external corners of rectangular elements resulting from the building thermal isolation application process. The corner profile can be made of plastic or aluminum. It is necessary to provide a mesh to ensure a secure connection with the facade reinforcing layer. We can use profile which we can use around the window, like this. This is the shape with the tape which we pull. and stick here a preservative foil, which preservative window during the install. And here we have a special profile which we which we use under seal. The reinforcing layer is to protect the APS board installation system to create a strong and durable prime coat for plaster work and to manage the facade thermal loads. Do not lay the reinforcing layer earlier than 24 hours after completing all works connected with fixing the EPS boards to the substrate. This period ensures that the adhesive bonding process is complete under optimum weather condition, a temperature of 25 and humidity of 55%, and the maximum layer thickness of 10 millimeters. Apply mortar on APS board surface as a continuous layer, thickness approximately 3 millimeters wide, slightly larger than the mesh IBB Therm M145 or mesh IBB Therm M165. The application process can be conducted using a notch trowel, notch dimension 10 per 10 millimeters, giving a coat of 5 millimeters. Stretch the mesh when you ensure that the entire material is evenly covered with the adhesive mortar. The adjacent mesh strips must overlap but at least 10 centimeters. Level the surface until the entire mesh surface is covered. Leave to dry for at least 48 hours. This period is to ensure that the adhesive bonding process is complete. After them, we can apply a primer. The reinforcing layer can be primed only after its bonding process is complete. After its application, provide the curing process take place under optimum weather conditions. Application of the primer enhances the adhesion of thin layer plasterwork to the substrate and facilitates work connected with applying the plaster coatings. It levels out the substrate absorptivity as well as the plasterwork bonding and drying time, eliminates stains and limits the effect of substrate color permeation throughout the plasterwork structure. Apply a plaster. Plaster are used to create a decorative and protective thin layer render coating and enhance the facade appearance. Our recommendation before and during application the plasters. Directly before use, mix the entire content of the packaging with a slow speed agitator with a basket mixer until a uniform consistency is obtained. Plastering works must be performed at a temperature between 5 and 25 degrees at a stable air humidity and no rain. Contact the application process and surfaces having a temperature between 5 and 25, not exposed to the direct impact of wind or sunlight. Newly applied mortars must be protected against rain and temperatures below 5 or above 25 degree until it's fully set. It takes about 24 hours. Each separate faceted section must be proceeded in one stage using materials from the same production batch. Now my colleague show how apply IBB Therm plasters. You have two kinds of plasters about floated structure and ribby structure. Wait a minute. If you want, please come. The first we have reverse structure. Spread the ready-to-use plastering mix in a thin and uniform layer on the substrate using a smooth stainless steel float. Next, remove excess render from the layer to ensure that the thickness is the same as the thickness of the aggregate containing the mix.
Do you have different size grit? The grit mix, do you have different size grit in the mix? Sand, the sand texture.
And we show in this structure we make moves up and down or right and left. My colleague
or is it silicone on that one?
we apply acrylic. Silicone plasters is applied in the same way. Now we have another structure plotted. In this type of plaster we after apply we have circular movements. Who wants to try? Apply.
So this separate bucket, does this have a separate sand content? Is the sand content different in this bucket to that bucket?
This is plotted. This other
Yes, so there's different. There's difference in the product, yeah.
The other one is for thinner.
Yes, that's what I was trying to get across. That's
The other one is one on the side, the one I think two.
Maybe someone wants try apply. And you do circular movement. thickness should be like sand. Is yeah, the side is sand, which we in the inside, because we have 1 millimeters, 1.5, 2 millimeters, 2.5, and 3 millimeters.
And what's the finish you can get? What's the finish texture?
One is ribbed, another is frotted structure.
19 jest 1.0 czy...
All of them have the same weight.
And how thick is this? What says? How thick is the? Is this 1 millimeter? 1.5? This is 1.5. So if we have right, and if we have 1 millimeter, obviously it's a smoother, slightly smoother finish. Right. And 1 millimeter is the smallest finish. Right.
How many meters gonna stay on that or that every section? When you see the bucket,
No,
you start no more than
That's 1.5. I decided it's due to When we've done it, we've had like 4 or 5 guys. So you get everyone all working in line.
so one putting the things on the other one.
Yes, you can have a couple of guys doing it, and then the other guys then come along, floating it, and you do it all in one thing. But you need to be organised. You know, like 5 weeks got all running that way you get consistent. If you've got one person who's doing one section, you get different, depending on how they rub it, you get different finish on. The only thing is when you start, that's what we found out. You can't stop. And that's what I've seen sometimes. It doesn't look great, but sometimes like a big house, expansion strip. You read it up. You can't do it like that. You can't do it because there's 10 million on a house in one go. So you'll put like this. Floor like a 4 mil one expansion joint. Yeah. Read it up to that. And then do the next one after that.
You can. Możemy to włączyć?
So that reinforcing metal report, we've had 50 reports, you should understand what's going on. So
Okay. When external wall isolation is applied, special attention must be put to openings, expression joints, covered surface and or joints with other elements of the building, since they are more exposed to weather and the system is more likely to be damaged in this place. It is therefore strongly recommended that the isolation system is applied there with special care. In the beginning, new windows with integral seal. Should the project incorporate new replacement window, the frames and seals should be designed to take account of the thickness of the external isolation system to be applied, and the new seals should be sized so that they allow for a minimum 40 mm overhang to the face of the finished external isolation system, and all new windows should be installed prior to the isolation of the external isolation system. It is recommended that the external isolation system is taken over the edges on the seal and frame, so that the wrapping provides the sound silicone masking should be applied. What about existing windows and seals with new overseal profile? Should the project retain the existing windows? It is generally not that the existing seals have insufficient overhang to allow for sufficient shielding of water away from the face of the finished system. Should this be the case, then a new overseal profile can be installed. This should be cut to suit each window and ideally have upstand wings to enable the render to overlap and to provide a watertight seal. The seal should be installed so that there is a minimum of 40 mm overhang from the face of the finished system, and all junctions should be finished with a silicone masking seal. I talk now about window door reveal and head details. All existing reveals and hits should be checked to ascertain the correct detail to be used. It's important that external isolation systems are designed to reduce the chance of cold building accumulation. What about when the reveal and head detail will is set back from the base of the existing wall, where there is sufficient strength energy for them?
No możesz sprawdzić, powinien być, ale możesz sprawdzić.
Frame margin should be present, and if sufficient margin, circa 50 mm is found, then there should be the introduction of a minimum of 20 mm isolation and render. The system to frame junction should have a stop bit and silicone masking applied, or silicone mastic to the base of render and the top of the start over. Stop bit and
No to zobacz jeszcze, nie? Odpal, czy jest realizm z audio.
Here we show how this What about when reveal and detail when existing window frame is flush with the existing wall face? When the frames are surveyed and found to be flush with the existing face of the external wall, the isolation boards should oversail the minimum 20 mm. At the render finish returned to the frame with the approved junction finish, being stop bit and silicone masking or a hidden masking applied to the base cold layer. Whenever reveal and detail where existing frames are retained, however, there is insufficient frame margin for cold bridge isolation. The design where no reverse isolation is provided is no ideal and will cause localized cold breeding. However, it is recognized that certain circumstances cannot be avoided, and the development of proprietary installed river trims should be considered. Now about roof isolation. In case existing overhanging soffit, where an existing soffit board is resigned, the system should be taken tight against the underside and a bit of silicone mesh applied. It is imperative to determine if there is evidence of existing isolation within the roof void that will ensure no cold breach will occur. Failure to check this may result in localized conditions and mold growth to the top of the internal walls. Existing press fascia boards generally are retained. Best practice would be to remove and extend the roof line sufficiently to accommodate the new external wall isolation system. However, where this is not possible, a new trim should be installed, mechanically fixed and sealed with silicone mastic. Trim should have a minimum of 30 to 40 millimeters overhang from the base of the finish system and any joints connected with proprietary jointing trims.
Rendering on normal things at the top?
On the top is trims, special trims.
And is that trim that you supply?
No, trims is above. We apply to the trims.
But do you supply the trim? Do you sell the trim? The trim that you're talking about at the top.
Yeah.
Do you make it? Do you supply it?
No.
So we have to provide that. Do we?
Sorry, but we don't.
I think you could use the same as the bottom.
They do the angle
Well,
mesh.
possibly, yeah.
No, they do the angle
There's
mesh.
holes in the bottom of it. That's the trouble. It's not solid. If you look at the bottom of that.
Same as the mesh and you render it?
They do the mesh.
There's a plastic something.
Mesh. If you want to do something, but they do the mesh. If you not do something, they do the
So mesh and render it.
Yeah. Exactly.
Okay, the next case.
Yeah, or a bit of leather. Something like that. Over
The following case, detail where existing flash fascia retained.
Existing gutter and line water down pipe are retained. With the down pipe outlet is retained, it is therefore recognized that the down pipe needs to be adjusted using a swan neck connection. This is the picture of this solution. Where this occurs, there should be sufficient protection to the edge of the installation, and as a G profile introduced to ensure water is directly away from the face of the finish system. Proprietary box profile systems are available and should be used for a series of trims installed to create a unit. Okay, thank you for attention. I hope that
Was for you interesting, and I show some aspects which are very important during external isolation system installed. Thank you.